Good morning, everyone. My name's Tim. I am the Silver Coder, and today we're going to be looking at a couple of ideas from two previous videos that I've done. And the first one was to do with deleting items from a to-do list, and the previous video was about dynamic arrays. And in particular, what I'm talking about here is we have a list of items, and we wanted to delete items from that list, and if we had a command line like this to do delete, colon 3, 1, and 4, the items are not in order. And in the video, when I spoke about deleting items, I said, well, if we were to, let's say, delete the items in the order we were given to us, then we could create havoc on the underlying list. And, to illustrate, if we were to take out item 3 first, then taking out that one there would now make item 3 to be, basically we would wind up with this result. So I'll just paste that down here and take out that one. That now becomes item 3, and whatever was item 5 is now item 4. So when we did get to processing the deletion for item 4, well, we are going to hit the wrong item. Similarly, if you were to, let's say process those in reverse order, you're still going to make a mess of it. So how can we fix this up? Well, what we need to do is to somehow we need to sort the items so that we can get them in some sort of order, for processing. So if we can get them, in, let's say, this order here, then, and we can then process them in reverse order, then we can guarantee that we knock the items out that the user wanted to be deleted, and only those items. So one way of achieving this, well, a simple sort function is the insertion sort, and I've got a reference to where you can find out more information about this sort on Wiki. But it is essentially a simple sorting algorithm that builds a final sorted array one item at a time, and what it does is iteratively inserts each element into its correct position within a sorted portion of the list. If you think of it, like you've got a set of cards, and you basically are going to work out where to put the card in the list, or in your deck, or in your hand, and you're basically going to be putting it into its correct position. Essentially, you are going to push items up to work out where the card goes. So we are going to look at the basically a modification slightly of our previous demo, where we were playing with a dynamic array, and you can see here now that we've added one more item in delta. So we've got an unsorted list of items, which we will then debug. We will then sort those items, and then show the sorted list. And after that, we're going to do a little bit more about, like so, from the command line. So the next part, so what we're going to look at here is, this is the insertion sort above here, which we'll just get to. These two functions here are from the previous demo, which basically just shows you the contents of the array. So you can see here that the insertion sort basically gets the it processes items 0 through n-1, or in this case here 1 to n-1, because we are going to be comparing each item to where it should be going, and then essentially pushing the items up so we can insert the element at to insert an element at a position into its correct position. And it does that, like I said, for each item in that list. So let's run this program here, and I'll just get my command prompt to use. And now you can see that the initial order was Bravo, Delta, Charlie, and Alpha, and as a result of the sort, we now have Alpha, Bravo, Charlie, and Delta. One thing I will point out is that it is important that if we look at this as being condition A and condition B, then if we were to flip those conditions around, our program would also be balked because of a range check error. So what we'll do now is to comment out this code here, and there might be someone at the door, so let's have a little look at that. Okay, so what we're going to look at here now is what we're going to get. Let's say we've got this string from the command line from the user, and that was, let's say provided here. There is a string helper function called split, which we can actually use to split a string, in this case here, based on the commas, and that will go into an array of strings. And we can see this here, and basically that will return, that, and that, by the way, is essentially an array of strings here, which is the same as what we were looking at previously, really. And like I said, how can we sort that? Well, or what can we do with that? We could either try and morph that into, well, we could either put S into a string list, but here really I think this is a far simpler way of, let's say, processing the elements, or to get the elements into some sort of structure. I guess the only cost is that we now have to really, have some function here to sort the elements. So the one way, like I said, one way you could do that is to, if I would just put a bit of code here, assume we've got the variables declared, let's say list equals tstring list dot create and then we would have to do something like list.comma text equals s, and then do list.sort, and then do let's say the code, and then list.free. We can either do all of that, or we can just do that. So for me, using in this particular instance here, using a dynamic array, it just makes more sense. And as again, all we have to do is to provide a sorting routine, and if we build this program again and go back to the command prompt and run it, then you can now, while the original list was 314, it is now in ascending order 1, 3, and 4, and if we did remove the elements in reverse order, 4, then 3, then 1, then we maintain the integrity of the list in terms of which items would be get deleted. So basically this is an alternative, shall we say, to using string lists. Or a good alternative, because also the other thing about dynamic arrays is you don't need to worry about freeing up the memory because they are reference counted, and I can also put a link to that in the description below as well. So basically the compiler or Delphi or the language handles the freeing of the elements once they go out of scope. So that's about it for the video today. If you do like this content or would like to see more of this content, let me know in the comments below. Also, if you've got something out of this video, it would be great for you to like and subscribe, and all those wonderful things to help the channel just chug along, because Pascal in its various forms, Object Pascal, Delphi, Free Pascal, etc. It's a good language and it deserves some more love, and that's what we're trying to do with this channel. So until next time, I will see you later, and bye.